These are the solutions for Algebra B Quarter 4, Test 2. And this is the study guide. And so let's take a look at our first type of problem here, Part 2, number 13 from the study guide. And it's a division problem. So we want to multiply by the reciprocal. So on multiplying, what we did in Part 1 is we rewrote it as the factored form, and that's what we're going to end up doing here. And so what we'll end up doing is changing this to multiplying and then taking the reciprocal. So the denominator is going to go up top, the numerator is going to go on the bottom. And so let's take a look at what we'll end up trying to do on this first part. First thing is I'm going to rewrite the 17, and then I'm going to multiply it by the common factor here. Looking at this part, I see a common factor of 3, so I'm going to take out a 3. So let's rewrite this. Put the 3 on the outside of the parentheses, so times by 3, and then I've got the x minus 2. So you see how I got that? 3 times x makes 3x. 3 times negative 2 makes negative 6. So I take a look at the denominator, and I see a common factor here of 5. So I'm going to take out a 5. So put the 5 on the outside of the parenthesis, do the distributive property, take out the common factor, and what you've got left over is an x minus 2. Okay, on top, 34 and 51 have a common factor of 17. So you pull out the 17, that goes outside the parenthesis, do the division. What's left over is an x plus 3. So what we can do is take out some common terms. See, the 17s will cancel, x minus 2 will cancel, but that's it. So what's left on top? Well, we got a 3 on top, 5 times x plus 3 on the bottom. So they could leave the answer that way, or you could end up seeing it in the multiplied form. 3 times by 5x plus 15. Either way would end up being fine. So looking at this next one, same sort of thing. It's a division problem. We're going to change to multiplication and then take the reciprocals. So that's what we'll end up doing. And rewrite the x minus 5. And then we go ahead and factor anything that we see. So 4x squared, no factors there except 4 and then x squared. Looking on in the denominator, we have a 2x, and then over here we have a difference of squares that factors to an x minus 5 and an x plus 5. And so what we can do from that point is do the taking out the common factors of x minus 5. The 2 goes into 4 2 times, and the x here will cancel out one of the x's here. So what's left over? Well, we got a 2x on top, and we've got the x plus 5 on the bottom of the fraction. Well, looking at the next one, same thing, it's division, so change it to multiplying and take the reciprocal. Got this negative 2x to the 6th on top, and it looks like we got a 5y on the top as well. And then down below, well, we've got this 7y, and the 4x is now going on the bottom of the fraction. And so what we can do is just take out common factors. So you see how the negative 2, well, 2 goes into the 4 2 times. This x down here is going to take out one of the x's here, leaving me with 5 x's. This y will take out this y down below, but that's it. That's all I can do. So what's left over? Well, I got 5 times 5 on top, so that makes the 25. Down below, well, we've got 25x to the 5th. So that's where I made the error. See, I was thinking 5 as a number, but 5 is an exponent. So let's fix that real quick. And so we've got a 5x to the 5th on top of this fraction. So we've got 5x to the 5th on top of the fraction. So 5 times the x to the 5th here. And then down below, well, we've got the 7 and the 2, so that makes 14. So there's our answer, 5x to the 5th over 14. Well, let's take a look at our next one. We got some common factors that we'll be able to deal with, but before we do that, let's just go ahead and take the reciprocal first. And so when we see this, we see how we've got this c squared plus 3c. So let's go ahead and take out that common factor of c first. So I'll pull out the c, put it on the outside of a parenthesis. I've got c plus 3. And then here I've got this other c, but that's actually going down below, so we've got to rewrite the c plus 1 on top. Well, looking at the next part, I've got a trinomial. It's going to factor as 2 binomials. And so when I look at this one, I see it factors to a c minus 1 and a c plus 3. See, the outside-inside terms need to subtract to make positive 2, and they do. And I've also got the c plus 1 on, actually c plus 1 was on the top now, so let's go ahead and fix that right now. It's just going to be our c term. And so now we can go ahead and take out some common factors. So I have this c plus 3 that's going to cancel. I've got this c will cancel out the c on top, so what's left over? Well, I got the c plus 1 over the c minus 1. Well, let's just go back and take a look at that first one that we were working on. I caught a mistake here. When I did the division of 17, 17 goes into 34 2 times, and so I need to add a 2 right here. And so when I do that, this is going to adjust this number right here. And so what we have here is a 2x plus 3. And so when I multiply out 5 times the 2x, we'll change this to a 10x. So let's just go ahead and fix that mistake right now. So again, learn from mistakes. Always check that work as you're doing your problems. And so again, my mistake again was dividing 17 into 34 and just getting 1. And I should have had 2x. Well, let's move on to our next problem here. It's a subtraction problem. That means we need to come up with a common denominator. So looking at this denominator here, we have 3x and then t squared. And so this one only has 2 x's and a t. So this one right here needs an extra x. So we're going to multiply it by x over x. Now this side, it needs a 3 and an extra t. So we're going to multiply it by 3t over 3t. And then we'll come up with a common denominator. Now before I multiply, I'm going to change this to an addition problem. Subtraction to addition, these two terms will change their opposite signs. And so now I'm going to distribute. And so what you need to do is distribute the x over both of these terms. So what we've got is a 4x squared, and then x times 2t makes a positive 2xt. And then over here I multiply using the distributive property, and I end up with a negative 15xt. And then looking at this one, 3t times 3t makes a positive 9t squared. So down below, what's there? Well, we've got a 3, an x squared, and a t squared. And so what we want to do is combine any like terms we can. So that's the common mistake people make, is they try to factor and then cancel. But you can't do that. You've got to combine like terms. These two terms are like, so they combine. So what do we have left over? Well, 4x squared minus 13xt, and then this plus 9t squared. That's what's on top. Down below, well, we just have that 3x squared t squared, and that's it. So that is our answer there. Well, look at our next one. No common factors on the bottom. We have an x minus 1x plus 1. So I've got to multiply this side by an x minus 1 over x minus 1. This side I'm going to do x plus 1 over x plus 1. So again, the key is you've got to distribute and then collect, and then the last part you factor. So what's left over here? We've got 2x squared plus 2x. And then I'm going to go ahead and just rewrite the plus sign here. And then this makes a 3x squared, and then a minus 3x. So down below, we just have the x plus 1, x minus 1. Now I leave that in the factored form on the bottom because we'll see what happens when we collect like terms and then factor afterwards to see if we can reduce. So we go ahead and collect like terms. So I've got 2x squared. I got the positive 3x squared makes 5x squared. And then here I got 2x and negative 3x makes a minus x, or minus 1x. Now down below, no common factors except for x, and once you take out the x, it doesn't help you out. So it doesn't help you to reduce this at all. So you can just leave it as x plus 1, x minus 1. They might end up multiplying out the denominators, so you could end up seeing it that as well, so I'll rewrite that. So x squared minus x all over an x squared minus 1 would be the factor what you get when you multiply it out, because the outside and inside terms cancel. Well, looking at our next one, we have common factors here. So you see, if you take out the 4 and you got an m minus 2, over here I've got a m minus 2 and an m minus 2. You see, factoring helps you see that we didn't need to multiply by the other's denominator. So this side needs an m minus 2. That's what we have to multiply by, over an m minus 2. This side just needs a 4. it'll make it go a little bit faster as we go with the problem. So we go ahead and distribute the 3m over this m minus 2, and we have this 3m squared minus 6m. And on the next part, we end up distributing, get this fixed there, okay, minus 4m squared is what we have here when we distribute this negative m squared over that 4. And down below, well, we've got the 4 multiplied by the m minus 2, but there's 2 of those m minus 2s, so quantity squared. So go ahead and collect some like terms there. You get a negative m squared, and it's a minus 6m. And you could take out the common factor of m, but it doesn't really help you out, so just leave it like this. And so you could go ahead and multiply out the denominator if you wanted to, or just leave it in that form. And let's see what the next part is here. We've got this, here we've got the same sort of thing. We've got an x plus 2 and x squared plus 3x plus 2. So we've got a common factor of x plus 2. But what does the other side need? Well, what it needs is, this x plus 1. And that's what it doesn't have. And so I go ahead and distribute. And so what we've got here is an x squared plus x. And on this other side, we've got this 3x plus 3. And then down below, we've got the x plus 2 multiplied by the x plus 1. And so we go ahead and collect some like terms. We've got x squared plus 4x plus 3, which does end up factoring. And down below, x plus 2 and an x plus 1. And so we could go ahead and factor the numerator of this, and when we do so, we end up with an x squared. Oops, let's go ahead and fix that. So it's an x plus 3 multiplied by an x plus 1. And then down below, well, we've got the x plus 2 and the x plus 1. So you can see how now we can cancel out a common factor of x plus 1. So what's left over? Well, we've got that x plus 3 all over the x plus 2. That would be our answer. Let's fix that real quick. There we go. So let's take a look at some word problems here. And we've got enough time to finish at least one of these. Might have to do the other one on another part. And so it says that Jan and Rhoda own a home remodeling business. They are putting finishing touches on the home restoration. Working alone, Jan can paint one room in 4 hours. And so what we're going to end up doing is setting up this job equals rate times by time formula. And so we'll start with remembering that the rate is the reciprocal of the time. So Jan, she can do the job, which is 100% completion, is 1 in 1/4. 1 out of 4 parts is done each hour, and then her multiplied by her time. And she does it in, again, 4 hours. And you can see how if I multiply these, 1/4 times by 4 gives me the 1. Well, Rhonda, she does the same job, but it takes her 5 hours. So 1/5 is her rate. See, if I times by 5, that gives me 1, 100% completion. So if I take these two and add them together, so this is working together, their rate is going to end up being 1/4 plus 1/5. So if I add those two rates together, multiply by the time it takes them to do it, it'll end up equaling 1. So we need to add these two fractions together. So I need to come up with that common denominator. So I'm going to multiply this side by 4 and this side by 5. So when I do that, I end up with this. I end up with 1 equals, and then I've got 5 over 20 plus 4 over 20. And this all gets added together and then multiplied by the time. That's what we're going to try to find. And so when I add that, I get 9/20 times by t equals 1. Well, if I multiply by the reciprocal, I'll end up finding out the time it takes her to do the job, or actually for them to do the job together. And so multiplied by the reciprocal gives me the time. So 20/9 is our answer. Well, 9 goes into that 20. We have 1 time with 2 left over, so 9 and 1 and 2/9. Actually 2 and 2/9. So it goes in there 2 times with 2 left over. So 2 and 2/9 hours is the time it takes them to do that job together. Well, I'll do the next problem on part 2, so check that part out.